Hello and welcome to Statecraft IAS Academy. I'm Atif, your geography teacher. Today we are going to learn about continental drift. Why? Because as I already told you, most of the topics that we discuss belong to current affairs in one way or the other. Today's topic I'm considering because of a news article in which the Czech geologists find oldest evidence of continental drift. This was an article and we will discuss about the article as well towards the end of the class. Now, since this is a news, so we should cover each and every aspect of such a thing, starting with the basic theory of continental drift. Okay, so let us start with continental drift. The theory of continental drift was given by Alfred Wegener in 1912, a German meteorologist. First thing, Alfred Wegener gave it in 1912. What is the theory? If you take a look at this image, this theory talks about how the continents have drifted over the period of time. For the past maybe 200 years, 200 million years, the continents have drifted. They are drifting even today. That's plate tectonic theory. But right now, we are not talking of plate tectonics, we are talking of continental drift. When we talk of this theory of Alfred Wegener, what he discussed in this theory was about 225 million years ago. That is when his theory starts. He talks of a supercontinent called Pangaea. What is a supercontinent? When the landmass was clustered at a single place. The entire landmass was clustered at a single place called Pangaea. First thing. So what is a Pangaea? First thing you should know is Pangaea. Pangaea is a single landmass. Now, this is the landmass. Around this landmass, we have water. Huge body of water called Panthalassa. Okay, now these are the two things that you should know first. The theory starts with Pangaea, a supercontinent, and the water body called Panthalassa. Number one, number two. But then he talks of some time like 150 million years back. Starting from 225 million years, 150 million years, the drifting of the continent started. The Pangaea started to break here. And this he termed as opening up of Tethys. Opening of Tethys. Tethys. What is a Tethys? It is basically a sea. A Tethys sea is a sea that is located between the two land masses that started to separate. The Pangaea, listen to me very carefully, this is a cycle that he has described. The Pangaea started to break around 150 million years ago, and a Tethys Sea, the water body in between the two land masses, is known as Tethys Sea. The two land masses that separated away from each other got their names as Laurasia and Gondwana. What is Laurasia and Gondwana? These are some terms that you should know. Let me tell you something. These are some of the terms that you should know first of all. First of all, it starts with Pangaea and Panthalassa. Pangaea is the landmass and Panthalassa is the water body. The Pangaea starts to split, and when it starts to split, it gets divided into two. What? Laurasia and Gondwana. Gondwana, the southern part, and Laurasia, the northern part, and in between we have Tethys Sea. This is something that you should have an idea of. After the Laurasia and Gondwana, the landmass further broke. First of all, let me tell you something. Although India is right now located in the northern hemisphere, but at this time, India was located in the southern landmass, that is Gondwana. You might have heard about it many times when you learn about the mineral resources of India, peninsular India. Peninsular India was a part of Gondwana. As I told you, the continents have drifted, the land masses have drifted. Take a look at third diagram. 100 million years ago, what happened was the landmass further started to break. North America and South American continent started to move westwards. They started to move westwards. Although the speed of North America, the drift of North America was more. The speed of North America was more as compared to South America. This is as per Wegener. Okay. And India was located here. This is India in the southern hemisphere. Moving forward, if we look at the Earth today, this is how the Earth looks. India located in the northern hemisphere and all the continents as we see the map. But as per Alfred Wegener, this is how the Earth that looks today has evolved over the period of time from 225 million years till now. Starting from Panthalassa, then two land masses, then further splitting up, and eventually the Earth that is today. This is the theory of Alfred Wegener, continental drift. However, there were some assumptions. What were the assumptions? First of all, he believed that there are layers, Sial and Sima, and the continents float, or the Sial. He termed the continental land masses as Sial. They float on Sima without any resistance. Remember this, because this will later be used as the criticism of the theory, whatever I am telling you. Without resistance. Without resistance. That is, it floats like, you drop an ice cube on water. How will it float? Smoothless. Very smooth. That is how he believed that the continents float, or the Sial floats on Sima without any friction. That was the first assumption. Then he gave his theories. What are the forces responsible for this? Which forces drive these things? Which forces? He gave two theories, two forces. One is the tidal force and the second is the pole fleeing force. Now listen to me very carefully. I'm going to tell you about the two forces. Kindly pay some attention. When we talk of tidal force and the pole fleeing force, he gave these two forces that were responsible for the continental drift. Talking of the tidal force, he discussed that the tidal force is because of the presence of moon. Okay, the moon exerts the force that causes the continents to move westward and eastwards. And this is how he described the movement of continents westward. That is, North America and South America started to move westwards. I told you already. Why did they move westwards? Because of this tidal force of the moon, of the force of attraction of moon. Is that possible? You think about it. Do you really think if that would have been the case, the tidal force is present today as well, then the continents will continue to move? Don't you think so? Right? So this was the first force. Second force was the pole fluct or the pole fleeing force. In this, he described two forces as force of buoyancy and centrifugal force. These are the two forces that are responsible for movement of the continents from the poles. How? He described that this is Earth, and because of the centrifugal force due to the rotation of Earth, the continents will start to move. We will have a centrifugal force acting somewhat like this. This is how the centrifugal force acts. And because of buoyancy, the continents will continue to move. Because the force of buoyancy will not allow the continents to settle. It will push the continents up. And because of centrifugal force, just imagine, this is the surface and we are getting a centrifugal force like this. So it will let the other regions to come towards this center, towards the equator. And this is how we describe the movement of the continents towards the equator. This force he used to describe the movement of pole fleeing. That's fleeing away from the poles. He described using two forces, force of buoyancy and centrifugal force. The centrifugal force that acts because of the rotation allows the other regions to come towards the center of the Earth. And then he used the other force, that is a tidal force, in which he explained how the continents started to move towards west. North America and South America. Well, both of the forces don't seem to be good enough, I know. But we will learn about them in criticism. These are the assumptions. Also, he was asked about the formation of continents. He explained the formation of continents. One more question that was asked was regarding the island nations. Now listen to me what he said about the island formation. There we have Caribbean islands. What he told is that when the continents were drifting, these parts broke from the continent because they were not able to keep up with the pace of the movement of the major landmass. Let's say this North American continent was moving with 10 kilometers per hour. Well, that's not the case, of course, but I'm giving you an example. He believed that these regions were not able to move with 10 kilometers, but with less, let's say 5. Hence, they broke away from the main landmass. And this is how he explained the formation of islands, especially the Caribbean islands. So, you can probably assume that this theory, although is a very important theory to understand the geological history of Earth, but there are many things that actually will come out as criticism of the theory, and we will learn about them as well. Okay, now why do we believe that continental theory can actually be true? What are the reasons that help us to believe? Of course, there are apparent affinity of physical features, botanical evidences, placer deposits, tillite deposits, polar wandering, distribution of fossils, rocks of same age across the oceans. These are some of the evidences that prove that continental drift is actually a fact. Actually, it's an established fact right now that continental drift has actually happened. But what the problem is that the theory has certain criticisms, certain drawbacks. As I told you, the forces that he described. Are these forces? No. The formation of the island nations. Similarly, other things, assumptions, sea floats on seama. What he stated is that when he talks of sea floats on seama without resistance, okay, let's talk of that in the criticism. Now we will talk of some of the evidences that are very important and that can be asked in your question, which will include the jigsaw fit of the continents, number 1. Number 2, the fossil correlations. Number 3, the matching of geological structures. And finally, the paleoclimatic indicators. First of all, starting with the jigsaw fit. You might have seen the jigsaw puzzle the kids used to solve when the pieces fit into each other. This is something that was used to explain this theory. When you take a look at South American continent and African continent, you will observe that South America perfectly fits in the African continent along this region, along the western margins. You take a map, if you don't believe in this, you take a map and see this will exactly fit in Africa. Okay, number 1. The same thing applies to other continents and well, if you take a look at Antarctica and Australia, Australia's bite. The bite in Australia will fit in Antarctica. India and Madagascar, they will also fit along the eastern coast of Africa. So the continents actually fit into each other. That shows that they might have been part of a single landmass. What is the landmass? The Gondwana landmass. As I told you, the Gondwana landmass, in which the India was also a part of, has actually shown us that these continents actually fit into each other. So this is the first evidence that might actually say that the continental drift has actually taken place. Okay, the second evidence, the Caledonian and Hercynian mountains of Europe. What are those mountains? You might be aware of the Scandinavian regions. We have regions of Scandinavia, Norway, Finland. Those are the regions where we have mountains. We have Jolan Mountains, Scandinavian highlands. These mountains form a chain along with the mountains of North America. We have Appalachians. You might be aware of Appalachian mountains. They are located in North America. Ideally, when you take a look at the map, what is the map? North America is located here and we have Appalachians somewhere here. This is the region of the Scandinavia where we have Jolan Mountains and other mountains located. Scandinavian highlands. There is Atlantic Ocean in between. There is no land connection between the two. But when we look deeper, the geological understanding helps us to figure out that they form a continuous series. They belong to a continuous series. They are same. They have the same origin. That may indicate that they might have been part of the same landmass once. Although right now we have Atlantic Ocean in between, but maybe back when the continents were joined together, they might have been a part of the same continent. And then the drifting started, the Atlantic started to form in between. And they separated. Number two. Third important thing when we talk of this thing is that the mountains that are located, where is the map again? See, I'll tell you, the gold is located in Ghana. You might be aware of this. Placer deposits. The gold is located in Ghana. But when we look at the rocks, because we will have rocks, the rocks that are actually the source rocks of the gold, they are located in the Brazilian highlands. Brazil is here and gold is here. How is this possible? How is the source rock located thousands of kilometers away on a continent that is located across the Atlantic Ocean, and we have gold somewhere else? How is that possible? That is only possible if these places were joined. Then only we can have the location. Am I right? Yes, that is another evidence where we find the placer deposits, the gold located in the African coast and the source rocks located in Brazil. That is another evidence of the continental drift. Coming to the third and the very important evidence is the presence of fossils. We have fossil presence. You know what the fossils are? Okay, we have a fossil of Cygnanthus, this, located in South America and Africa. How is it possible? That is possible only. Now, this is a reptile that cannot swim. First of all, let me tell you, these are reptiles that cannot swim across the Atlantic. You might be thinking that, okay, they might swim across the Atlantic and go to Africa. Well, they are not supposed to swim. They are not believed that they would swim. First thing. Okay. So, if we have fossils located in South America and Africa, we should know that these might have been fused. The continents might have been fused sometimes. These are the fossil evidences. See, if you take a look at the UPSC paper 2023, I think there was a question asking about continental drift. What is the continental drift theory? And give geological and fossil evidences. In geological evidences, you can give the evidences that I discussed before this slide. The rocks, the jigs of it, the presence of a continuous series of rocks, the placer deposits. When you're asked about fossils, then you have to discuss and give these examples. First, I told you about the South America and Africa. Then one more fossil of Listosaurus. Listosaurus is located in Africa, India and Antarctic. How? Now imagine if you take a look at the map today, India and Africa are located thousands of kilometers apart and Antarctica is at the South Pole. Then how is it possible that we will have the fossils of the animals on the three continents? There is a very good possibility that the continents would have been fused together. Only then this fossil is located along the three. Just a second. Okay. Now, coming to another fossil. Now, these were the animals. Let's talk of a floral evidence, that is Glossopetris. This is also mentioned in your NCERT as well. So you should know this name, Glossopetris. This is located in South America, Africa, Antarctica, India and Australia. That means all the continents that we believe were fused, we have one source, that is Glossopetris, located in all the continents. That's why I told you to memorize this name, remember this name, because this is a fossil that is located all along these continents. That's Glossopetris. There are some more names, you should know a couple of names. Remember Glossopetris, remember Listosaurus, and maybe one more, and you can quote these in your answers. This will make your answer more better when you quote the examples. Remember one thing, you should always use examples while writing your answers. This makes your answer look good. Let's go to next evidence. That is the presence of light deposits. If you take a look at the map of the world, where is the map? See, this is India. Okay. When we talk of peninsular India, tell me something. This is located in the tropics. This is the Tropic of Cancer. So when we talk of peninsular India, it is located in the tropics. That means the temperature here is usually high. It is usually high. Okay. Is it possible to find tellite deposits? What are the tellite deposits? Basically, when we talk of landforms, every action of every agent has its distinct landforms. For example, when we talk of water, it leads to V-shaped valleys, right? Then it goes for meandering, monadnocks. Similarly, when we talk of wind, it leads to geogens, yardangs, mushroom rocks. Waves have their different types of. When we talk of glaciers, glaciers also form specific types of landforms. They also leave their imprints. This is a geological concept as well. Different processes leave their geological imprints. And that's what I'm trying to tell you here. The glaciers leave tellite deposits. Are you getting my point? See, okay, this is the evidence that I told you about tellite deposits. Glaciers will leave their tellite deposits. They leave their deposits. Now, if we find the tellite deposit somewhere, what do we understand? That this area might have been under glaciation. The glaciers would have been present in this region. Maybe not today, but sometime in the past. Can you imagine glacier being present in a tropical region? Even during the ice ages, when Earth was taken up by ice age, even then the tropical regions were free from ice. Not thinking about any other times, think of the ice age, when most of the Earth was under the cover of ice. At that time, even the tropics were not under ice at that time. Just imagine, can you imagine this peninsular India under ice? Then how are we able to find the tellite deposits in India, in the peninsular India? Just imagine, you're right now in Karnataka, you're right now in Tamil Nadu, you're right now in Hyderabad, any other place. Can you imagine a glacier there? Not possible. It's not possible. So how are we finding the tellite deposits there? How is that possible? That is only possible when the India was not present in its present location. It would have been present somewhere else. As I told you, it was present in the southern hemisphere. And once upon a time, when we take a look at India, during the Carboniferous Ice Age, India was located at the southern hemisphere along the South Pole, almost on the South Pole, and it was under glaciation. When we were under Carboniferous Ice Age. At that time, India was so far in the south that it was under the ice. Glaciers were present, and because of that, the tellite deposits were present. And even today, they are located at some places. We still find evidences. And that is how the scientists or the geologists believe that India has actually moved from that region and is located at its present day position. But once upon a time, it was located in far south, where it was under glaciation, and that is why we are able to find glaciers, the glacial till or the tellite deposits. This is one more evidence. Now, when we talk of one very important evidence is, let me ask you something. You know about coal. When we talk of coal, tell me what is the mechanism that leads to development or formation of coal? The vegetation undergoes the burial, right? If you take a look at this map, the vegetation, well, it goes underground, it leads to formation of coal. I'm just asking, you know how the coal is formed? It needs hot, humid temperature for the formation of coal. And that temperature is located on the tropics, in the tropics, and not in higher latitudes. Tell me, we know some of the largest coal fields are located in Germany, the Rohr coal field. You know about Rohr? And similarly, some more coal fields are located in Germany, in Europe, in China, in the northern regions. How is that possible? These are the regions where we have usually witnessed cold temperatures. And coal does not require cold temperature. It requires moist temperature, warm temperature for the coal to form. And the best quality coal is found in these regions. How is it even possible? That means maybe sometime back in history, these regions would have been present at a location where the temperature was hot and humid. And that's actually true. If we take a look at the map of Earth, let me just draw it for you. You should also know how to draw a map quickly, because in exams, when you're writing mains, you won't have that much of time. You should be able to draw a map in maybe 10 seconds, 20 seconds. Okay. You don't have to be a real artist there. You just have to be able to show how the map. This is the map. This is Europe. This is the region of cold dominated region in Europe. In glacial times, in the Carboniferous time, I'm talking of Carboniferous period, the equator is believed to be located along this region, like this. Because at that time, the continents were not like this. They were not arranged the way they are arranged right now. They were arranged in a different pattern. And the equator is believed to be traveling through Europe. So the temperatures here would have been hot, moist, right? That is why we find coal in this region. Now, tell me something. One second. Yeah, tell me something. Is nothing now clear to you why we find coal in these locations? Otherwise, the conditions in these regions don't support the coal formation. But once upon a time, during the Carboniferous period, when the maximum coal, the Carboniferous coal, is the highest quality coal, when we find the Carboniferous coal in these regions, that is because the equator used to pass through these regions. Don't get confused. It's not that the line today equator passes somewhat like this. It's not that the equator would bend. It is just that the continents were arranged in such a way that the equator passed through these regions. And that is why in these regions we find coal. Are you getting my point? So this is one more evidence of why we find coal in these regions, why we find tellite deposits in India, even though India is located so far south, it's in the tropical region, because back then it used to be in those regions. Now let's talk of some criticism of the theory, because in exams you will definitely be asked about the criticism. Okay, so what is the criticism of the theory? First of all, Wegener said that the Sial floats on Sima without any resistance, that there is no resistance. And then at the same time, he told, when he was asked about the formation of mountains, you know how he explained the formation of mountains? He explained that when the North America and South America were moving westwards, due to resistance of the movement, because the Sial was moving on Sima, because of the resistance, it led to the formation of mountains, that's Rockies and Andes. Initially, he told that this moves without resistance. Just imagine, he's contradicting with himself. He said that the assumption is that it moves without any resistance. But then he talks about the formation of mountains, especially Rockies and Andes. And he talks about the friction or the resistance that leads to crumbling of the boundaries of these continents that eventually led to formation of mountains. That's Rockies and Andes. The boundaries of these continents crumbled because of the resistance, which led to formation of Rockies and Andes. Hence, this was contradictory. Again, this only talks about the formation of mountains along the boundaries. What about other mountains? What about Himalayas? What about Urals? What about Appalachians? He could not explain that. He tried to fit in these things in his theory. You try to fit it, but this does not fit because you are assuming that there is no resistance. But then when you are explaining the formation of mountains, you're talking of the resistance. That's not possible. That is a self-contradiction, and that is why this is not correct. This is the resistance. Number two, the forces that he talks of, the tidal force and the pole fleeing force. As I explained to you, in the tidal force, he talks about how this North America and South America started to move towards west because of the pull of the moon. But as I told you, is it even possible that the continents are moving under the action of moon? Because the tidal force is today present as well. The moon is still attracting the continents, but we don't see such a thing happening. We don't see such a thing happening. Coming to second force, that's pole fleeing force, where I told you the maximum is located along the equator. This is also not sufficient. This doesn't agree with because today we have a theory of plate tectonics that is much more comprehensive, that is much more complete. Although it also has certain limitations, we will get that theory as well, because eventually that is the theory you will require in the exams. But the forces that he used were not good enough. Now comes the question, if these are not the forces that are responsible for these movement of the continents, then what are the forces that cause the drift? As I told you, that drifting is a fact. Drifting is something that is a fact. It's not that drifting is not true. Drifting is true. But what about the force that is responsible for drifting? It was explained by Arthur Holmes. Arthur Holmes was a person who gave the concept of convectional current theory. He explained why there is movement of the continents, why the lithospheric slabs move. He explained it in detail. Basically, he talks of the region of asthenosphere. As I have already mentioned about the asthenosphere in the previous class, it is a zone of weakness where we have semi-solid state of matter. In this region, there is continuous radioactivity, as per Arthur Holmes. Because of this radioactivity, what happens is that there is radioactive decay, the temperatures increase beyond levels. There is very high temperature in certain regions. Because of that, the area is in semi-solid state, because everything melts in such a region. And this causes the movement because of these convectional currents. Just imagine the movement of convectional currents. Let me show you how the things are. This is one plate. This is a second plate. Okay. So underneath we have asthenosphere. In asthenosphere, there is constant convectional current. Now what happens is that whenever the current is moving like this, somewhat like this, it causes the divergence. It will move the plates in the same direction. The plates or the lithospheric slabs or the continents will move in the direction of the convectional current. If the current is moving in this direction, then the plates will also move in the same direction. At the same time, if we reach a place where we have convergence, suppose a convectional current is coming from this direction, like this, what's going to happen? The convergence will lead to subduction. This is something we will learn in plate tectonics. We need a class on that as well, because that's very important. We need to learn about earthquakes, the volcanoes that will come in plate tectonics. But right now we need to understand how the things are actually taking place. What is a convectional current theory? It has two types. One is the ascending limb and one is the descending limb. The ascending limb causes the rupture of the plates, the movement of the plates, and the descending limb will lead to subduction of the plates. This is again a concept of plate tectonics. Right now you need to understand it was the convectional current theory that provided a missing link to the continental drift. Continental drift, although provided a lot of information to us, it provided us a lot of information about many things, but there were still some criticisms, still some drawbacks. It did not explain any proper force that led to the drift. Okay, we agree that once Africa and South America were fused together. We agree to that. But what is the force that is responsible for their movement apart from each other? The force was provided by Arthur Holmes by his convectional current. It is the convectional current that is developed in the mantle, more specifically in the asthenosphere, that causes the continents to drift or to come together. If the convectional current is moving in this direction, the continents will drift apart. If it is moving in this direction, then the continents will come and fuse together. Where did the fusion take place? India coming towards Laurasia, Asian plate, fusion, formation of mountains. This was provided by Arthur Holmes. And this provided us with the proper force that is responsible for the continents to drift away or come towards each other. One important thing that you need to know here is that one more evidence of the continental drift is provided by Atlantic Ocean. When you take a look at Atlantic Ocean, you know about mid-Atlantic ridge that is present here. Why is it formed? Because of the divergence. That means because these plates are moving westwards. Now imagine the plates moving westwards. One plate is moving in this direction. So in between we will have a formation of a rift or a mid-Atlantic ridge because of continuous coming out of magma. How is that formed? That we will learn when we talk of volcanoes right now. Just remember that mid-oceanic ridge or the mid-Atlantic ridge is another proof that yes, America, North America and South America have drifted westwards. And it was finally the force of convectional current that filled in the gap of the this continental drift theory. Now, when we take a look at the article that I initially stated, in this the scientists from Charles University in Prague, where is Prague located? Any idea? Discovered the world's oldest evidence of horizontal tectonic plate movement in Canada. Basically, it is a curved mountain belt 2.7 billion years old. Okay, the mountain is 2.7 billion years old. What's the age of Earth? Do you have any idea? Big Bang? 4.5 billion years. You know about the geological time scale. I hope you know about it. If you don't know, then I will need to bring a class on that as well. You just let me know. If you want, I can do that as well. But right now, this mountain is believed to be 2.7 billion years old, formed by collision of lithospheric blocks. How is it formed? Because the lithospheric blocks collided together and that led to curved mountain belt. Now, this is very obvious. If we have something like this, something hits this region, what's going to happen? We'll get a sort of a curve, somewhat like this. And that is exactly what I'm trying to tell you. This is a research by the scientists of the Prague University. They found a mountain in Canada. Well, this is not that big news, but just it was in news. So I thought you should know about continental drift. You might not directly be asked about the news because it's not that big a deal, but you should know about the continental drift. Many times UPSC, state PSCs have asked the questions directly about continental drift, and they have asked you to critically analyze, because this is a theory in which there is a lot of criticism. So you should be able to criticize. What is the criticism? No proper force, because the pole fleeing force or the tidal force is not sufficient. Number one, Sial floats on Sima without resistance. Again wrong. Formation of east-west mountains or the north-south mountains, Andes, Rockies. Again contradicts with itself. So these are some of the theories. You might also wonder, sir, you told about the Pangaea formed, the drift started some 150 million years ago. So why are we talking of 2.7 billion years? Let me tell you something. There are many cycles of the continents coming together, forming a supercontinent, then going away from each other, then coming back, going back. It's not only Pangaea. There are other supercontinents that have been present in history. Rodinia, one such example. That was a supercontinent maybe 400 million years back. That broke, then came back together and formed Pangaea, then broke again and is a present world. Maybe in future, these continents might fuse back together and form some different supercontinent and then break again. This has been taking place throughout geological history. That is why I told you geography as a subject is very interesting. If you go as far as possible, you will know about Earth. Of course, assumptions, but there are some evidences, there are some proofs that actually prove that things are correct. So that's all from my side in today's class. I hope you understood everything. If you have any confusion, kindly let me know so that we can solve your problems. Till then, bye-bye. See you in the next class.